All right, we have the laws of logarithms. Combinations of multiple logarithmic terms can be combined together to make one single logarithmic term. So you're going to make one single logarithmic term after you combine them, okay? Using the laws of logarithms. Conversely, one logarithm, so if you go backwards, you can take one logarithmic term and you can split it up into two or three or more or less complicated terms using the law of logarithms. You will need to memorize these laws. So you need to memorize these, okay? Here are the first three. Let b be the base of a logarithm. So this is your base. B is the base. And m and n be positive numbers or variables. Now remember, your base has to be greater than 0 and it cannot equal 1. So in this case, notice if I have log base b of m times n, we can split that up into two things. Log base b of m plus log base b of n. Since this one is a division, we're going to split it up into a subtraction. So when you have log base b of m divided by n, that's going to be log base b of m minus log base b of n. And then finally, when you have it raised to a power, log base b of m to the k power, you can split it up. You can actually bring that k to the front. So k times log base b of m. Okay? So those are the first three rules that you're going to have to know. The fourth, now, if you look at this right here, this was the first one, and we're going to do a couple problems that resemble this. So whenever you multiply problems, whenever you multiply them, you're going to split them apart, and you're going to make it an addition problem. For instance, if I were to give you this problem here, log base 10 of 5ab. Notice that 5a and b are all multiplication. So you can split this up into log base 10 of 5 plus log base 10 of a plus log base 10 of b. And you have three separate terms. Okay? I'm going to do one more for you. What if I gave you log base 5 of 8x to the third? You can split this up into log base 5 of 8 plus log base 5 of x to the third. Now, we're not done with that one yet. We're going to continue that one here in a moment. Okay? Now, if I go to this next one, if I have a subtract or a division, what if I gave you log base 10 of a to the fifth over b to the third? Well, because it's a division problem, I'm going to split it up into log base 10 of a to the fifth minus log base 10 of b to the third. Okay? Now, that's basically what you would do whenever you'd have a division problem. But there's also one little thing now. Rule number 3 says that if you have a power, you bring it to the front. So going back to this one, when I have this power, I bring this to the front. So this is actually 5 log base 10 of a minus, bring this power to the front, 3 log base 10 of b. So now you have three rules that you have to combine all together. Okay? All right, now, so let me give you one that incorporates quite a few of these. For instance, log base 2, 6 squared, x squared, y to the third. I have three terms. So this is log base 2 of 6 squared plus log base 2 of x squared plus log base 2 of y to the third. Now I have to go through and I have to take these powers and bring them to the front. So 2 times the log of base 2 to the 6 plus 2 times the log of base 2 of x plus 3 log base 2 of y. And that's expanded form. That's all you're doing is expanding these for right now. Let me give you one more example. All right, let me go ahead and give you one more example. What if I had this one here? What if I want to go from expanded to condensed? If I gave you log base 5 of 7 plus 3 times log base 5 of x. Now notice, there is a 3 in front. That's got to go back to a power. So step number 1, log base 5 of 7 plus log base 5 of x to the third. Now that I've got that back into the power form, I'm going to go ahead and combine these. And that's going to be, since they're both log base 5, this is going to be 7 times x to the third. Okay, so this is where we're expanded here, and here we're condensed. Okay, let me give you one more problem. If I gave you 3 times log base 6 of m minus log base 6 of n over 2. Now this looks a little different, but you're going to have to realize that this 3 goes right here. So this is log base 6 of m to the third minus. Now, remember, that right there is actually 1/2 log base 6 of n. Now, I'm going to bring that back to as a power, and I have log base 6 of m to the third minus log base 6 of n to the 1/2. Now, what I can do is, since I have only the subtraction left, I'm going to write log base 6. Now remember, when it's a subtraction, it's actually goes back to a division. So it's m to the third divided by n to the 1/2. And this would be the condensed form. So this is your expanded form. And this is your condensed form. All right, condensed. And the last thing I want you to know is this little thing called change of base. All right, let me get rid of that. All right, change of base formula. Okay, evaluating log expressions. There are times that you must use a calculator to evaluate a logarithm. However, calculators are only programmed to use common logarithms unless you have a Casio, lucky for us, the logarithmic function with base 10. So one of the things you can do is if you have a base 10, notice this is log base a of x. Okay? What we can do, if this and this do not match, we can change this to log base 10 over log base 10. The x goes right here, and the a goes right here. So with that being said, now we have log base 10, and typically if you have the TI calculators, you can then put this in the calculator because our calculators are base 10. So for instance, if I want to change a base, if I have log base 2 of 25, I simply write log base 10 of 25 divided by log base 10 of 2. So this base now becomes of. All right? And or you can actually, since we don't have to put this base 10 here, you can simply write it as log 25 over log 2. And those are your notes for tonight's lesson.